Hi everyone, in this video we will take a look at the actual MCP server and understand how easy it is to manage and govern your Kafka clusters with the help of an AI client and the actual MCP server. So here we have the Cloud Code CLI installed, and we are adding the MCP server for actual, which is running in a test environment. Next we start the Cloud Code terminal. Using the /mcp command, we can take a look at the current status. It needs authentication. The MCP server supports OAuth authentication as per the latest spec of MCP. So we click authenticate and we are directed to the key close screen, and we can just authenticate via the already existing IDP, just like we do with the actual self-service. So here you are authenticated as the user that you are. Now we can also take a look at the various tools that are available: create Kafka topic, producing of messages, and many others. So what we'll do here is we will create a Kafka Streams application with a simple filtering application. We will use the actual KSML to build the Kafka Streams app using the MCP server. Let's say we have a bus journeys topic that contains the bus number as string key and JSON value containing the details of the bus journey, like source and destination, cities of Netherlands, and the status, which can be boarding, driving, delayed, etc. We will let the AI add some of its own ideas as it sees fit. Please draft a KSML definition to read from this topic, filter the bus journeys that are delayed, and produce it to another topic named bus journeys delayed, the same key and value type using the KSML definition resource. And do not create any topics just yet, because that's the next step. So now the AI is, in this case, the Sonnet 4 model is kicking into action. So it reads the KSML definition MCP resource. Because KSML is not in the training set of the AI model, we need to teach how to write valid KSML syntax, and that we can do using the MCP resource. And here we see that it has created a YAML file with the streams input and output defined, key type string, value JSON, and a function that will filter out delayed journeys looking at the status, and the pipeline that reads from the input topic, applies the filtering function, and produces the messages to the output topic. So looks good. So let's create the Kafka topics in actual, then deploy the KSML application for this use case, get necessary access to the topics, and start the application. And also use the MCP testing environment and MCP group to own all the resources. And now this is where we'll see the actual MCP server doing its job. So the Cloud Code will create a bunch of to-dos. And the first two are to create the input and the output topic, bus journeys and bus journeys delayed. Here it is. It has created the two topics in parallel and applied the correct group and environment. We also see the key type is string. And now the next step, it is registering the KSML application, which is also completed. And the relevant credentials are also generated automatically. So the app will run in the background on the server side itself. Then it is requesting the access to the topics. It has asked for consumer access on the source topic and producer access on the target topic. Note that we did not explicitly specify this. The model was intelligent enough to figure that out. And finally, the application is started. So now let's look into the self-service of what has been created. Here's our pipeline. It reads from the bus journeys topic, and the filter application has been started currently. Here is the definition that was originally generated. It has been correctly registered here. Okay, and the app is started now. Let's check the logs. Seems to be running. Okay, so now let's produce some messages and test whether the filtering logic is working correctly. The producing of messages is also something that is supported by the Axual MCP server. It relies on the KSML data generator. So that's another KSML application which simply produces messages as instructed. Here the model will also take care of generating the messages as per the topic schema itself. So here it has called the API. Let's take a look. There's our producer application. And yeah, there we see bunch of messages produced. Let's browse those messages. Yeah, we have 50 messages produced. Let's take a look. In the value, we see bunch of information added by the model itself: destination, driver, route, passengers. A lot of this we did not instruct. The model just chose to add contextually correct information on its own. And we have a bunch of different statuses: driving, boarding, etc. Now, since the filtering application is already running, so we should see some filtered messages here. So there are 12 messages. These should be only the bus journeys that have their delayed status. Yeah, looks correct. Okay. Now we can also ask the MCP server to get some information about which bus journeys are currently affected, they are currently delayed. This prompt is understood by the model to translate it into a browse action on the destination topic. So it has called the browse Kafka messages MCP tool and retrieved those 12 messages, and then it will give us a summary of this information. There it is. Nicely structured in a table format. The source and destinations, the cities that are most affected. Quite a good summary, I would say. And finally, we can stop the application, and our filtering application should be stopped. Yeah, so that's it. That's the Axual MCP server.